Okay, so the next thing we're going to do is confidence intervals. So we're going to be splitting chapter 8 in half. So we're going to be doing confidence intervals for population proportions. We're going to be doing confidence intervals for population means. So essentially we want to know where the actual answer lies. So essentially you need a point estimate, which is either a sample mean or a sample proportion. Okay, which is an estimate for the actual population proportion or the population mean, right? So you don't know what the real answer is. That's the point of statistics. Okay, the real population answer can only be gotten if you have all of the samples, which is a census, which typically is very difficult to impossible to do. So you need to estimate where the true answer lies using the samples, basically. So at a local college, a random sample of 100 students is taken in to find the average age of students. The sample mean is 22.3 years of age. So the real answer for the actual population is probably more or less than that. It might be the same, but typically it doesn't match it exactly. So the sample mean of 22.3 years, that's why it's X bar, it's a sample, right? Is the point estimate for the population mean mu. Right, so we'll take that, copy that down to there. Okay. Oops. All right. So a sample estimates this. So it's a, this is the point estimate, right? Because it gives us a point of reference. You can think of it that way. Okay. At a local college, this random sample of 100 students is taken. That found 51 0.9% of the students are enrolled in liberal arts. What is the point estimate and why? The sample proportion, p hat, that's not what I want. Hold on here. Is the point estimate for the population proportion P. Notice how they always put a little hat above it to make a sample, right? A little hat above it means sample because X doesn't need to be what the mean is. It could be any letter really. Okay. All right. So the estimator needs to be unbiased, a consistent estimator, and relatively efficient estimator. So you must meet these three qualifications to be a proper estimator. If you don't meet those three, you're not. So the things we care about are the confidence interval and the confidence level, essentially, which are not the same thing. Okay, so this is the confidence level here, and this is a confidence interval. Typically, you don't write it like this. I'm doing this as an example. So typically, you'd write 0.421 is less than p, which is less than 0.617. That is the proper way to write it. You shouldn't be writing it in percents. The book does, so I did give an example that does that essentially. Okay. So, and again, given a confidence interval of this, with a 95% confidence level for the random sample of 100 students in liberal arts survey, interpret its meaning. Okay, so we're eventually saying whoops, sorry, wrong thing. We are 95% confident that the true population proportion of students enrolled in liberal arts is in the interval 0.421, comma 0.617. Okay? All right, that's what essentially we're saying by giving that math, essentially. All right, and one thing I will say is a lot of times in Stats 2 they'll show this notation. I don't particularly like it because the fact it doesn't tell you whether this is a proportion or a mean or anything else. Essentially, this is like the universal way of showing a confidence interval, or this is the classic way. I'd rather you do it this way, where you actually show the letter in between. And again, notice it's not equal to, it's just less than or greater than. And again, that's why it's parentheses here, because it's not equal to, essentially, so it's consistent. So we believe the true answer is in here, and we're 95% confident in that. Okay, so confidence level, confidence interval, two different things. All right, so the way that you calculate a confidence interval, which I just gave you the one in here, is an estimate, which is the sample, plus or minus the margin of error. Okay? All right, so the first half of Chapter 8, we're doing one sample proportions, right? The second half we'll do one sample means, again, for population. So this is our estimate, right? This is our sample, and this is our margin of error. Okay? This is our sample. This is our margin of error. So notice it's plus or minus, right? Plus or minus. Okay? So the standard error, right, is, p times q divided by the square root of n, right? So that's what we did in the prior chapters with the central limit theorem. So if you multiply it by the z value, you get margin of error, basically, right? So the confidence interval is in here, essentially, between our two values. That's our confidence interval. Okay? Okay, so the z value, you notice it's z alpha divided by 2. Like, what is that? Well, that is known as the critical value. Okay, so it's either z alpha divided by 2 or it's z asterisk. Z asterisk is the old way of doing it back in the typewriter era. This is the more modern way of doing it, essentially. Okay, so the significance level and the critical value are related, essentially. So if you have a confidence level of 90%, right, then 1 minus 0.10 is 0.90, correct? So the significance level, right, denoted by alpha, is 10, and the confidence level is 90. Okay, they're related. So if I want a 90% confidence interval, alpha is 10. If I want a 10% if I want a 95% confidence interval, then alpha is 5. If I want an 80% confidence level, alpha is 20, or 0.20. Okay? Okay, so why is it alpha divided by 2? Well, let's talk about that. So these are the values the textbook gives you, which I don't want you to use because these are rounded values, and if we do things that are in hundreds and thousands, the problem is it'll make your answer off by quite a bit, essentially. So let's figure out, why is 95% confidence level using this z value? Why is that? Okay, so let's do an example here. 95% confident. Okay, so essentially, if we want a 95% confidence interval, this is 0.95 here, right? So we're 95% sure our answer falls in this region, which means alpha is 0.05. Okay, 0.05. That's not very good. Let's redraw that. Okay. 0.05. So half of alpha is 0.025. Right? And same thing here. 0.025. And why is that? So if we're 95% sure our confidence level interval is in here, then 5% of the time it's either more or less than what we actually think it is, which is 2.5% essentially. Okay, so that's why there's two z values. There's this z value here and this z value here. Okay, so divided by 2. There's two of them, right? So this alpha divided by 2, and this is alpha divided by 2, except this is the positive one and this is the negative one, right? And we don't need to account for the positive or negative because the plus or minus in the margin of error accounts for that. Okay, and these are actually the same value, just positive or negative. Okay, and we can figure these out in the computer, which is what we're going to do. So here's the reason why I go through this in more detail than the book. Students will take 95 and put it in the computer because they didn't pay attention, and they'll get every one of these wrong for the entire chapter 8 and the entire chapter 9. Or yes, chapter 8 and 9. Do not put this number into the computer to get your z-value. That is not what's going to happen, because you need to go from here to here, which is not 95, right? So from, because again, this goes out forever, right? So from here to here is not 95, because you have to account for this also. So this and this is 97.5, correct? So let's go to the spreadsheet real quick. Spreadsheet. You do the online one or the local one, doesn't matter. You get the same answer. So I'm going to do z, and then we're going to do 0.05 divided by 2. That's our alpha, right? Okay, so normal dot inverse 0.975 comma 0 comma 1 close paren. Because again, let's draw a picture here. Okay, we're doing a confidence interval like this, right? So 95 is right here. So it's 5% alpha, correct? Alpha is the 5%, which, right, that's our, okay. So this is therefore 0.025. So if you add those together from here to here, you get 97.5, correct? Okay. So from here to here is just this area, right? So alright, so if I hit enter, I get this here. And if I do normal dot inverse 0.025 comma 0 comma 1, okay, we get the negative value essentially, right? So notice this is 195,996, right? And this is 196, that's the rounded value, correct? So this is the 1.95996 dot dot dot, and this is the negative 1.959 dot dot dot, keeps going forever. Okay, so the point is, don't use these ones they give you in the book. Don't round it, use the exact value the computer gives you essentially.